Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking a piece of silicon is doped uniformly with phosphorus with a doping concentration of 10 to the power 16 per centimeter cube. The expected value of mobility versus doping concentration for silicon, assuming full dopant ionization, is shown below. The charge of an electron is 1.6 times 10 to the power minus 19 coulomb. The conductivity of silicon sample at 300 Kelvin is what? So they are asking for the conductivity, and also initially they have mentioned the silicon is doped uniformly with phosphorus. Phosphorus is a pentavalent impurity, right? So we are going to have N-type semiconductor. So when we dope with a pentavalent impurity, this is a N-type semiconductor, right? So this is N-type, which means we are going to have donors most of the time. Okay, and they are asking for the conductivity. Since we have N-type, we are going to find out what is sigma N. But conductivity for a semiconductor generally given by this equation: Nn Q mu N plus Pn Q mu P. Okay, and here we know this is an N-type semiconductor, which means we are going to have majority carriers are going to be electrons and the minority carriers are going to be holes. So we can say Nn is going to be relatively larger than Pn. Okay, it means this value is going to be huge amount compared to this one, so we can neglect this one. So we can get rid of this one and equalize sigma n to this value. So approximately we are going to have sigma n is equal to Nn Q mu n. Okay, and actually Nn is nothing but number of donors added. So number of donors added is the Nd value. Also, when we say N-type, Nd value is given right here. This is the concentration. This is the number of phosphorus with a doping concentration of 10 to the power of 16 per centimeter cube. So this is the donors added. So that is given by 10 to the power of 16 per centimeter cube. So instead of this one, this Nn is nothing but the number of donors added. So we can say this one is approximately equal to Nd Q mu n. Okay. Now we have Nd value that is here, and Q is the charge of the electron that's given in the question. We have to find out mu n. Mu n is mobility of electron at room temperature. Okay, that is given in this graph. And if you look at this one, we are looking at 10 to the power of 16. So 1e plus 6 power plus 16. So this is the one we are looking for, right? So if you look at this one, the first one is for holes. They have mentioned this dotted diagram is for holes, but we are not interested in that because we neglected that one, right? Because that's going to be relatively smaller than Nn. So we don't have to worry about this part. We have to keep going to the top one, and that's for electron. And if you look at this one, that is at that point we are going to have 1200. So that's going to be the mobility of electron at room temperature, 300 Kelvin. Okay, now we have all the values. So all we have to do is just plug the values and find the final answer. Nd is given by 10 to the power of 16 and Q is given by 1.6 times 10 to the power of minus 19 coulomb. And then we have this mobility, we just find it out, that is 1200, and that's going to give us 1920 times 10 to the power of minus 3. And if we simplify this one, if you multiply by 10 to the power of minus 3, we are going to have 1.92 mole per centimeter, or you can say Siemens per centimeter. Okay, both units are correct, and that's going to be our final answer for this question. So this is 1.92, and that's how we do this kind of problems. I hope this helps. Thanks for watching.